Well, greetings pinball fans and welcome to another episode of Alpha Bravo Pinball. In this episode, decidedly not live, we are going to attempt a repair on my latest machine. As you can see, Whitewater has joined the garage. Very happy to have found a machine. It's in great shape, plays amazingly well. It's rare that I will buy a machine this old, 30 years old now, that plays as great as it did, but I bought it from a fellow collector. It's in amazing condition. It has the coveted topper that is very desirable on this game. Some don't have it, but mine does. I'm lucky to have it. However, there is one minor problem with the topper. It may look like it's working great. It has this really cool waterfall effect as there's a sequence of lights, and the actual part with the waterfall that you see is not flat. It's a die-pressed 3D shape that was very specifically designed so when the sequence of light fires, it gives you an effect of water flowing down the waterfall. And really cool attention to detail at the bottom of the waterfall. The water looks like it's going up as it hits the bottom of the waterfall there. Super cool effect. Very happy to have mine. Let me show you what's going on with the topper. All right, so here we have a close-up view of the Whitewater topper. It's functioning pretty much perfectly. The light sequence may appear random at first glance, although only that very specific light sequence is what will lead to that waterfall effect. The problem that I have is the third lamp from the right is burned out, and you may be thinking to yourself, why not just replace the light? Of course, that's the first thing that I did, but it's burned out for a reason. It's burnt out because the control circuitry that's supposed to flash it on and off is not. The lamp is on 100% of the time if I replace it, which leads to its burning out. So of course then the actual problem is we need to figure out what's going on with that lamp control circuitry and why it is keeping that light on 100% of the time. All right, so here we are with our light board, and I have printed out a few pages from the manual here showing us how the light board, all the components and the connectors and the wiring, and this will help us greatly when trying to see if we have a fried transistor controlling that one light that's out. So the light that we care about, of course, is L6 here, the third from the right on the right board. So if we go down here at the bottom right side, L6, this is light 6 here, is connected to J1 pin 9. And so if we go down here, J1 pin 9, that's the one that we care about right there. Black gray from Chaseland board goes to J3-10. So at the other end of this connector is J3-10, which is on this light board here. So here is the light board schematic itself. And we can find pin 10 here, which is connected to transistor Q16. The way this light board works is a couple of ICs, and then each light has its own individual Darlington pair transistor, which is one component here, two transistors in one component. The lettering is tiny. It is a 2N6427, so we're going to need a spare 2N6427 transistor. So like I was saying, that's Q16 according to this. If we look at this page here, we'll be able to find Q16. And so this is our board, and this is the exact layout. So here is Q16 right here. So if I put this like this, you should be able to see that that corresponds. And so Q16 is right here, which means this guy right here is the transistor in question that is suspect. Whenever you have in a circuit like this something that's stuck on or stuck off, it could be that the transistor is fried. So it's very easy to pull it out. Instead of testing it in circuit, I'm just going to pull the transistor out, and we will test it and compare it to a known good one to see if indeed this transistor is fried. It's not a guarantee, of course, that that's what's going on. It could be not the transistor that's fried, but these two ICs through which the signal goes could also be bad. I mean, they're not complete, it's only one light that's out, and so that's why I don't think, my intuition tells me it's not going to be just the individual lines on these ICs here, which by the way are these guys here, it's not going to be those that are probably the most likely failed component. I'm going to go with this transistor is pretty much, along with the resistors, the only component that is unique to that light. So we're going to start there. Alright, so I have my trusty Hakko 808 desoldering station here heated up and ready to go. Again, we're dealing with this transistor right here. I'm going to do my best to try to give you a view of it being sucked out here. Can't say that I've ever done desoldering on camera before. I finally have all 3 holes clear there. What a mess. That was way more tricky than I was expecting. Sometimes that's just what happens though. Luckily it's a simple board, and if we burned off the pad or the trace, we can just run a jumper wire. It shouldn't be a big deal. It's totally repairable. Alright, so here we are testing a known good transistor against the one I just pulled out. And from one side of the transistor, you can use your diode check here, about 0.6 volts, which is normal. And then on the other side, because it's a Darlington transistor, I imagine it's double at 1.2 volts. And then every other combination should read overload. Alright, so completely normal here with the known good transistor. Now, to my surprise, if we measure the one I just pulled out, there you go, 1.2 volts on one side, 0.6 volts on the other side. And every other combination is reading open. So the conclusion is, I went through all that work to pull this transistor for absolutely nothing. But of course, since I have a good one, we're just going to, I'm not going to put the old one back in. We're going to put the new one back in. Well, I think this is going to be it for today, folks. This is the state of the game now. As you can see, we made it worse. The topper now no longer works at all. On off camera, I actually tried a spare chase light board that I had. I did not know the state of it. It was bought in unknown condition just to have as a backup. After I replaced the transistor and it didn't make any difference, I figured, what the heck, I'll try the backup board. The topper stayed dark with the backup board, and much to my chagrin, even after putting the original board back in, the topper is still dark. Wah wah. So seems that just the fact of trying that spare board seems to have made things worse. Now, of course, this new problem is unrelated to the third light from the right being out, but nevertheless, we have 2 things to fix now. All right, so I've made a few discoveries worth sharing here. So first of all, yes, I know this is confusing, but I have a spare board here, and after my repair failed, I figured, well, what the heck, I'll try the failed board, or the spare board rather. Didn't know the state of it. It turned out when I put it in, the topper went completely dead, no activity whatsoever. But worse, when I put this original board, which I attempted to repair, back in, everything was still dead, no lights on the topper. But then I noticed, and I've been thinking through dinner and stuff and looking at schematics, I made some discoveries. So this LED here was not on when I put the board back in. And if you look at the schematic, this LED is right here. And it pretty much just goes, it gets the AC power here, it goes through a bridge rectifier, and then immediately that goes to the LED. And so if the LED is not working, it means you're either not getting AC power, or the bridge rectifier is bad. We know that this board has a good bridge rectifier though, because otherwise you wouldn't have just one lamp out, you would have an entire board out. So that led me to conclude that this AC power was not coming through. If you look at how this is wired, this will basically connect to so this is J1 here, and J1 goes to the power driver board at J105 right here. So if you look at J105 on the power driver board, J105 is right up here, and note it's next to 102, and you would have to look at the full schematic of the power driver board to know this, which is a very large piece of paper, but it is basically wired directly to J102, which comes from the transformer with a fuse. So there's F111 here, which basically connects directly J102 to J105. So I was pretty sure that what had happened is the spare board that I put in blew this fuse, because there's basically almost no circuitry between the transformer and that LED. It's literally just a fuse and two bridge rectifiers, which we know are good, and then the LED. So logical conclusion, of course, the fuse is blown. And so this is this F111 fuse, and indeed, it's got a burn mark on the side. I know it's hard to see on camera. Oh, you can actually see it. Yes, it's got a burn mark there, and that fuse was blown. So what most likely happened is my spare board has a shorted bridge rectifier. When this bridge rectifier is shorted, of course, you will pull an enormous amount of current through that AC line. It'll blow the fuse. So back to my original board, which we are attempting to repair. I found it very, very suspicious that I had, the transistor for the light in question. We're talking about L6 here, just to refresh your memory. I found it very suspicious that the transistor for that was good. Pulled it out, tested it, it was good, and of course I put a new one in just because you might as well put a new one in. But it just doesn't make any sense. Every other component that's unique to that lamp is just resistors, which don't go bad, and then ICs, which we know are working. So the next thing that I did is I took my multimeter off camera and measured basically AC voltages between these pins here as the to try to see if the lamp board was actually getting power to all of the lights. And I was expecting, of course, to not be getting power at J19. 9 being, of course, we looked earlier, lamp number 6 here, which is here. Lamp number 6 is connected to pin number 9. I was expecting not to get power at pin number 9. To my surprise, pin 9 was getting power. Then I took... Well, that's very mysterious then. So I basically measured every pin on the connector and found that actually pin 11, the very last pin, did not have power. Then I took a closer look at the board and the traces on the board. And what I found is that actually it's not... Unlike this, which indicates that lamp number 6 is connected to pin number 9, lamp number 6 is actually connected to pin number 11. It's an error in the manual. It's clear as day. I could measure continuity and confirm, and sure enough, it's pin 11, not pin 9, that's connected to that lamp that's not working. And so, well, maybe there's other errors in the manual, but actually it does seem to be the only error. The next thing I did is look at the color of the wire going to that pin number 11, and as per the manual, it was indeed black and blue. And black and blue, it says here that, J111 goes to J35, and so I confirmed at the other end on the actual board here that it is J3 pin number 5 that goes pin number 5, which is right here. That is black and blue. So what does that mean? Well, it means we replaced the wrong transistor. Indeed, it's not Q16 connected to pin 10 here on the board that's bad, but it would be that transistor has nothing to do with that lamp. It's actually pin number 5 here, which is connected to transistor Q14. So, well, the next step then is let's look at Q14 on the board and see if that transistor is bad. Okay, so Q16 here, that's the one that I originally replaced, which was the wrong one. And if you look closely, that here, this last one is Q14. So it's not in a bad place to replace. It's right on the edge of the board, so it should be just as easy, not easy, as the first one. But before I go through the trouble of actually removing the transistor, figured I would just measure it in place. We can compare it to the others too to see how they work. So let's start with the one that I just put in. If I go like this, I should see about 1.2 volts. That's good. And then I go to the next one over, 1.2 volts. It's good. And then the next one over, 1.2 volts. Skip that one. Next one over, 1.2 volts. And then we get finally to Q14. Nothing. There you go, folks. This transistor is the bad one. If you look really, really closely, I don't know if it'll show up on camera, there's actually a little bit of a black spot right around that transistor too. It's really subtle, but it's darker than all of the other transistors, which reinforces to us that that is actually a bad transistor, and replacing it should fix our light that's out. So let's connect the desoldering station and get to desoldering it. Alrighty, I had much better technique, much better success on that one. Pretty clean. And there you have it. We have our new transistor in. Let's see if it works. So here we are, the game is back together, and indeed it is working perfectly. It was indeed, the manual was wrong about which transistor that light that wasn't working was connected to. Once the proper transistor was swapped in, the topper is working perfectly again. I hope you found this useful, and please stay tuned again for more Alpha Bravo Pinball. Thanks, good night everyone, play some pinball and stay safe.